powered by Riverside FM.
Welcome to the Science Edit, the podcast that breaks down the trickiest parts of science and helps you get it right when it matters most. I'm Miss Lima, and I'm here to support you with the science you need when you need it. Whether you're revising for exams, exploring future careers, or just trying to figure out why your last test didn't go so well, you're in the right place. Let's dive into our next episode. Today, we're exploring common reasons why students lose marks in GCSE Chemistry. I'm joined by Mrs. K, who's been teaching chemistry for 25 years, and also a Year 12 chemistry student who's an aspiring medic. So let's start. Why do I keep getting it wrong? The chemistry basics. So welcome everyone, and thanks for joining us. Before we get into the topics, can you tell me, from your experience, where do students most commonly lose marks in chemistry?
It's the really obvious answer, really. It's not reading questions thoroughly. And that technique goes through every single exam they do in every single subject. It's easy to say, read the question better or make sure you're reading the question properly. But students need to, before they go into an exam, have a technique which allows them to read the question properly and not miss anything out. So before I tell you about techniques I've heard that work, what do you use?
Normally when I'm in an exam, I tend to underline any keywords or key details. So that could be statistics or like percentages, things like that. And I read the question at least 2 times before I actually go into answering it. Obviously there is a bit of a time restraint when you're in the exam, but I'd say maybe skim read it first, underlining key details, and then go back again, read the question fully, and make sure you really understand it before you try and attempt the question.
I love that. I think that's actually a really good technique, not just for chemistry, but for all sciences. We tend to find that happens a lot across the board, and it's a really, really good habit to get into.
What I'll add to that is, I agree, it's really good what you're saying. One thing which helps across all subjects, which is also worth some students considering, is rather highlighting command words, i.e. the instructions. So are they saying describe? Are they saying explain? Are they saying interpret? Because that will give you an idea of what depth or what type of answer you need to give.
Are students aware that they're often losing marks, not because they don't know the science, but because they're not showing it clearly in their answers?
They can only really find out if they are losing marks in past paper questions. They'll never find out in the final exam if they're going to lose questions or not, because they never see that paper again. So I think this will be something that's going to come up quite a lot today, is you can only ever find out where you're losing marks if you're doing lots and lots of past paper practice. And I think you were saying earlier that was such a key strategy you used in your GCSEs.
When I was doing my GCSEs, I spent a lot of time, obviously learning the content using flashcards, I'd say is the best way for chemistry, but also just going over exam questions. The more exam questions you do, the more you understand the exam technique. And I feel another tip is just believe in yourself when you're in the exam, because there's a lot of times where the answer is on my page for many of my test papers, but I just seem to think I doubt myself, and then I go and change it and it's obviously wrong when my original answer was right. So I think just trust yourself in the exam and you're going to be fine.
That's really powerful. Some students see a question and immediately decide not to attempt it. What kind of questions in chemistry causes that reaction?
I think it's like a lot of these questions, it's the same for most exams. It's unfamiliar questions cause students to not attempt it. They think we haven't done that in class, so therefore I can't do it. I think there was a common one in biology where all the learning was round a potato one year, and then in the exam they asked about a carrot. And then there was lots of complaints we haven't covered the carrot in lessons. So again, as I said earlier, this is going to come up a lot. The way to get around unfamiliar questions is to make them less frightening by actually trying past papers which contain unfamiliar questions, and then you realise that you're able to do it because it's more about a common strategy or technique you're using, not about the unfamiliarity and having to know how to tackle that.
Let's just move on to some of the topics. I mean, obviously, chemical equations and balancing equations is a major skill that students have to learn. What are the common pitfalls people will find with that?
I think sometimes people get hung up on chemical equations. They think in order to get a level 9 in chemistry, you have to be able to balance equations. You do have to know how to balance equations to understand chemistry. But in terms of marks given in an exam for balancing equations, you're not really looking at more than maybe 3 or 4 marks. However, they are important because they underpin lots of calculation questions where you have to look at ratios and so on. So firstly, direct marks, they probably don't lose a lot, but indirect marks through things like ratios, they would lose marks. So the best way, actually, before I say what I think, I don't know if you could say how you got over balancing equations.
Well, I think I used to struggle with them at first, but I think I spent about an hour on YouTube looking at different ways people did it, and I found that writing out the numbers in front of the elements and let's say 2Na or something like that, you write it out and you do it on both sides of the equation, and then you figure out how to balance it. So it's just taking each step slowly and not making sure you're not just kind of guess it in. You write it out and you make sure you've done it properly. Another thing is, I'd say don't spend too long on it, because it could be a mark and you're probably just overthinking it and you end up spending loads of time on it when it's actually just easy and the answer's right in front of you. So just come back to it if it stresses you out and you're not getting it the first time round, because a lot of the times if you come back to it, you get the answer afterwards.
Checking your formulae is important as well, isn't it? Because if you've got that wrong, you're going to end up balancing it wrong. And actually, you could probably tell, if you're struggling to balance something, it might be a thing that actually go back and check, are my formulae right? Because it shouldn't be this difficult.
Often, if they're asked to balance an equation, they often put the formulae down, but you have to balance it. And I think it's interesting what you said about balancing. It sounds to me you use a number method to work it out. It really does depend. Not everyone can use that method. It really depends on the way you learn. You might be a visual learner, and so you might need a different way. So the best way to find your way is to actually ask your peers to maybe teach you. One of the ways will stick, and then you go online and put practice balancing equations, and there are always sites that come up with lots to practice.
Thank you. Let's move on to another tricky topic that lots of students struggle with, which is electrolysis. It seems to baffle students. What's the most common pitfalls that people find with electrolysis?
It's quite an abstract concept, electrolysis, so that's the first problem. Everything you're talking about, you've never seen. You're talking about charges, never seen those. Ions, never seen those. So you have to have quite a good imagination to get through electrolysis to start. Often, one of the biggest problems is trying to work out, or the part students don't like most. In fact, I'm going to hold it in my head and see if I'm right. What did you think?
I did not like electrolysis, but I think I did spend a lot of time learning it, and the more, you just need to make sure you really, really learn it and memorise it, because once I did, I remember I was getting all my marks in that section of the paper. So it's definitely one of those things which is, it's hard, but then it's doable. You can learn it. And I think just take the time and really learn it, and then you will be fine in the exam.
There are some tricks to it, aren't there, about learning what goes to which electrode, etc., like which ions go to which electrode. Can you share some of those?
There's rules to whether it's molten, so in a liquid state, what goes to each electrode, and then there's ones, if they're an aqueous solution, the products are sometimes different because you can make hydrogen gas or oxygen gas instead of the substance you've put in. Again, it is about finding a way to learn about that and practicing it, drilling it until you understand. So what I'm trying to say is, to start, when you do the first few, they are really, really hard. So if you do 5 questions like that, where you're trying to work out what's formed, that's fine. But you need to do about 15 or 20 till you get the pattern. It's like trying to learn to juggle 3 juggling balls. You know, you can kind of get it after 2 minutes. But if you want to be really good, you've got to do it for 2-3 hours to get really good at it. And it's the same with the electrolysis rules. You've got to practice lots and lots of questions to really get the pattern stuck in your head.
So I guess the key takeaway is that electrolysis is predictable. If you learn the rules, you stop guessing and start scoring. So if we move on to calculation and moles, that always seems to be a really big topic that students struggle with. And why do they cause so much panic?
I would say if you're not comfortable, which is probably about 40-50% of students, it's all about learning how to do some of the question. You've got to remember these marks are worth 4 out of 4. You don't have to get 4 out of 4 in questions like that. 3 out of 4 is still 75%. You can work out the level of 75%. You can get your marks from parts of the paper that you're stronger on than just the maths. It's all about picking up the 1 mark here and there with mole questions. Some of you then will get better and better at that and move on to another level. But as long as you're not getting 0 out of 4 and moving straight on, it's all about picking up the marks for the easy parts, like working out formula mass, etc.
I always say that. I was just going to say that. That's the first thing I always say to a student is if you don't know where to start with a question, just take the formulae that you've got and work out the relative formula mass of all of the substances that you've got, because that will be mark worthy, and actually it could even lead you into a step in the right direction. So
I think
it's quite good.
Another thing you always taught us was to make sure all you're working out is very clear.
Yeah.
To not just to the examiner, but to you as well. Very important. So make sure you've written that the moles of this or the MR of this, so then you don't get lost halfway through.
That's right. Yeah, you have to. If you've just got a page full of numbers and your brain drifts out for 3 seconds, when you look at the numbers again, you don't know which number matches up to what. So you should always just put in brackets by the side what that maths is indicating.
I'm just going to move on to one other topic, which is rates of reaction. I mean, this seems to be quite a straightforward topic on face value, but actually there's some real key terminology that students need to make sure they include, otherwise they are going to be dropping marks. Could you just tell us about that?
So the main keywords is you've got to talk about the particles, and you've got to talk about the frequency of successful collisions.
Understand what the word valid means, understand your variables, etc. as well.
I also think, again with this, if you learn the key terminology, I think it's very easy to get marks on this. If you don't know it, it's hard. It's one of those things, you repeat it, look at the mark scheme, see how they mark, and then over time you'll understand what the examiner expects of you.
That's great. Listen, I want to thank both of you so much for your time today. I just want to leave with one thing. If you were to give your top exam technique to a year 11 student facing quite important year ahead, what do you think it would be? Sorry, I know I'm putting you on the spot here.
I think it would probably be, the way I revised was do flashcards and make sure you know the knowledge. But I think also things like moles, just practice the exam questions. The more you do, the more used to it you're going to be. And another thing that does work for me, not so much in chemistry but in other subjects, it was blurting. So just maybe make a mind map on the topic and then go back to it on your whiteboard or just on another sheet of paper. Just blurt everything you can remember, and that's a really good way of trying to make sure
powerful.
You learn it.
Yeah.
I agree. I think they're really, really good tips that you've given. I'd say I would add on to that to do past paper questions like you suggested. I would probably start by doing past paper topic questions by topic first as you get on physics maths tutor, and when you feel confident of that, then build it into whole papers so the questions are more mixed.
Thank you so much for joining us today. It's been so useful, and we haven't covered nearly as many topics as we would have liked to. If you've got any tips for revising chemistry that you think that we could include in our next episode, then please do drop us a line in the comments section. I'm so pleased you were able to join us for the Science Edit, and we'll see you in our next episode.